So, good morning, everyone. The Energiewende is the Nordic way. I don't know if the Icelanders have anything to teach in this respect, but certainly we have been through a lot of changes recently, and we are on the middle of a very, very steep learning curve. I am a geologist. I have been working in management and finances all my life. Different companies. I've been the CEO of this company for a year and a half, and sometimes I call myself a financial geologist, whatever that is. But in this presentation, the geology will certainly come through. There's a certain teaching element in me. Anyway, Orkuveita Reykjavíkur is the Reykjavik Energy Company. It's the utility serving 2/3 of Iceland with hot water for house heating, with power, cold water, sewage services, and fiber optics to the homes. It's a big company on the Icelandic scale, but it is merely a dwarf on the European arena. So let's go to the presentation then. This is Iceland. It is located on the mid-Atlantic volcanic ridge, stretching all the way from the North Pole to the South Pole, 20,000 kilometers long, and it's all volcanic. Iceland is all of volcanic origin. It is the most active volcanic part on this mid-Atlantic ridge. It is one of the most active volcanic spots on Earth. We don't know why, but there is a hot plume of molten rocks rising from great depth from the mantle of the Earth up through the crust underneath Iceland. The ambassador said that we had obviously been blessed from above. I don't think so. I think it's from below. Well, we are blessed from above as well, because we have a path of low pressures crossing Iceland regularly, sometimes more regularly than we would wish, and that gives rise to the hydropower. So most of the power production is hydropower, 75%, 25% is geothermal power, but it is increasing all the time. Then, of course, the house heating, which is extremely important, that is all geothermal. 90% of all houses in the country are heated directly by geothermal energy. Well, you see the distances from Iceland to Europe. You can see it better here. We are in the middle of a feasibility study, the third one, for a cable connection from Iceland to Europe. And the shortest distance for a cable would be to northern Scotland, about 1,000 kilometers. That would then be almost twice as long as the longest subsea cable today. And if you go for Europe, continental Europe, it would be about 1,500 kilometers. It is technically possible, and now it seems to be coming economical as well, with the higher prices and the possibilities that exist on the market. This will be, if we go along that route, the most difficult environmental debate ever embarked upon in Iceland, I'm sure, if you come to that stage. This is an example of the hydropower stations we have. We have done our projects in a very, very good manner, high quality, both in preparations, construction, and particularly in operation. Good hydropower is the best you can find. Of every type of power production, good hydropower is. And it is certainly a part of the renewables. It is sometimes forgotten. People look only at wind and solar today. Good hydropower is the best you can find. But unfortunately, it is a limited resource. And Iceland is approaching its limits on utilizing hydropower. This is a simplified geological map of Iceland. You see the volcanic zone coming from northeast to the southwest, and the red dots are active volcanic centers, and these are volcanoes that can erupt any time. We have two types, basically, of geothermal systems. We have the so-called low temperature, which is up to 150 degrees. That is what we define as low temperature. Then we have high temperature, which is above 250, from 250 to 1100 degrees centigrade. In between, there is a certain uncertainty how to where it is. But you see here, these are very high temperatures. Iceland is spreading from east to west because new material is coming up constantly along the line of active volcanism. So the eastern part of Iceland is moving towards east and the western part towards the west. And when the rock comes out of the volcanic zone, it cools down slowly. The black spots are so-called low temperature areas, including Reykjavik, where there's a lot of hot water being pumped directly out of the ground and into the houses. So what is geothermal power? A little bit of a lecture here. It is not very well known to most people, so I'll give you a sort of a shock treatment. This is a cross-cut of the globe. This is the Earth we own, or should we put it the other way, the Earth that we belong to. We have the core, we have the outer core, we have the mantle, and we have the crust. And we made a simple attempt to calculate what is the size of the geothermal resource that could be utilized by mankind. And we made a simple calculation. We say that the crust of the Earth is 10 kilometers, so that is the accessible part of it. So we calculated the volume, which is a simple exercise. We have measured the specific heat content of the rocks. We can do that in a laboratory. We take a piece of rock, we heat it from 0 to 100 degrees, and we measure how much energy goes into it. And that is then the energy that we can get out of it again. We know the temperature of rocks. We have the gradient. The global gradient is 30 degrees per kilometer when we go deeper. That is the average. In Iceland, it is 5 times higher, 150 degrees per kilometer. If we multiply these three together, the temperature of the rocks, the specific heat content, and the volume of the crust of the Earth, we come to a figure that is 5 billion exajoules. 5 billion, and exa is a number with 18 zeros. Mankind uses 400 annually for all energy needs. If we could take 0.1% of the heat energy stored in the crust of the Earth and put it to effective work, it would be sufficient for all energy needs of mankind for 13,500 years. So this power resource is enormous. This is just to show you that there is no lack of geothermal energy. We are not running out of energy. The only question is, how do we get at it? How can we put it to work? I also want to point out that geothermal energy is the product of a decay of radioactive material in the mantle and the crust. So it is then, by definition, nuclear power. A much more traditional nuclear power than what we are using in our nuclear power stations. And I also want to point out that this is our own proper power. It comes from our own Earth, whereas the rest of power comes from the sun, being solar energy or wind energy or hydropower or fossil fuels or whatever. It's all borrowed from the sun on a long-term agreement. Anyway, so there is no lack of geothermal power. It's just a question of how to utilize it. This is a location we have, or geological setting in Iceland. Iceland would be located in Topia, so there's a short distance down to very, very hot rocks. Well, this is Reykjavik back in 1933, before we started using hot water for heating our houses. This is the same today. This is the cleanest capital in the world with respect to air quality. These are hot water tanks here to supply a part of Reykjavik with hot water, and there is a restaurant on the top of it. It's owned by my company, unfortunately. If you want to buy it, it is for sale. And we are going through a very thorough restructuring of the finances of this company, and successfully. So this is one asset that is certainly for sale. Well, there is a blessing from the geothermal. Geothermal has added a lot to the quality of life in Iceland. It's not a question of money only, because this is a cold country, and if you can enjoy heat, abundance of heat, you can keep your house as warm as you like, as big house as you like, and many people, they still control the heat or the temperature by opening and closing the windows. That's how we do it. Then we have some 150, 200 public swimming pools all around the country. Most of them are outdoor, and they are open around the year. This is one example in Reykjavik, and many people, they go there every morning, particularly retired people, and they start the day by sitting in a hot pot here, 40 degrees for half an hour. And if you want to hear all the latest news that are not in the newspapers, you go there. So this is a part of good quality of life. Here you see a picture from one of our high temperature geothermal power stations. These are all built on or within active volcanic craters. This one produces 120 megawatts of power and some 400 megawatts of, well, equivalent of hot water that is pumped down to Reykjavik for house heating. So this is a combined heat and power production for power and hot water. This is another one, a brand new power station producing 303 megawatts of power, 130 of thermal for heating houses. We'll go up to 700, 800 megawatts within a few years, including the district heating part of it. This is the power production in Iceland since 1915. Very, very slow, started here picking up in the post-war period, and then over the recent years it has been almost climbing vertically. And this is the reason that we are today very much looking into civic participation in energy issues. Where are we and where are we heading? We have abundance of energy resources, power resources, for the size of the nation, but the nation is very, very small, just 0.3 million people, 300,000 people, that's all. For this small population, we have abundance of power, but the power has a limit. And when I was young and working as a geologist, studying the power resources, we all felt that we would have enough for forever. We could just continue building power projects and there would be no end to it. Now we have seen, for various reasons, that this is not true. Technology has advanced very quickly. Our ability to build fast with technologies that we didn't have before, like full-phase tunneling machines. Our last power project had 72 kilometers of tunnels, most of them just bored with a boring machine, no blasting. And so we can, with the modern technology, build as fast as we like. We have the scientific knowledge of the power resources, both geothermal and hydropower, so we can embark on any new project anytime. We have, or we had until recently, access to endless capital at low capital cost. So basically we could, if we did not, or if we wanted to, we could build all the remaining power resources and harness them within the next 10 years. Do we want to do that? That is the basic question. How far do we want to go in utilizing the power resources? How fast? How shall we build? How shall we use the power? Shall we use it at home? Shall we use it for power-intensive customers? Shall we build a cable and connect to Europe, an umbilical, and sell power to other markets? What parts of Iceland do we want to preserve for the future? These are very, very, very hot issues, and there's a fierce debate in Iceland about all of these issues. So we are trying now, the parliament, the politicians, they're trying to find a way to come to a common understanding. Where are we? Where do we want to go, and how fast? To what extent? We are 100% renewable in power. We are 80% renewable in total energy usage, all included, including imported fossil fuel. This is of course marvelous. We have the power resources, and we have been lucky enough or wise enough to utilize them properly. This is the power consumption in Iceland per capita. We are a little bit above the rest of the world. You take Germany here, and you have Norway, which is very, very power intensive. We are more than double Norway. So, Norwegian colleagues, we just left you in the dust behind us. Well, the reason for this is that Iceland is not very rich on natural resources. We do not have forests, we do not have mines. We do have two things, that is the fishing grounds in particular, and we have the power resources. And then, of course, we have the country itself, which is a jewel. If you haven't been there, I recommend you should. So we have more power than we need, and we sell it. We export it, sort of. We do not have a cable, so we import the customers. So we have imported power-intensive customers, particularly the aluminium companies and ferrosilicon and other investors that need a lot of power at competitive prices. Not lowest prices, but competitive prices. So 80% of all the power we use today, 80% goes to what would be an export if we had a cable. So power-intensive customers. Then if you combine, if you compare our power usage, we say 80% for the power-intensive, then we would be quite similar to other European countries in power usage per capita, or even lower, because we don't use power for house heating, we use geothermal for house heating. So this is the big picture. Rapid changes. We could harness all remaining power sources in 10 years. Is that what we would like to do? This is, if you take top down, this is the way legislation works. At the top, we have the Republic's constitution. Then we have the parliament and the law. We have national resources policy that touches upon all natural resources, and we have a national energy policy, and under that we have a master plan for energy options that we have been working on for years and years now, and is really giving result. Then we have strategic environmental assessment for master plans and the national zoning. Then we have another picture like this one when you go further down in details. Many of these are being worked on right now, and some of these have just been started. If you take a look at the next picture, the Constitution is under revision, and we have a national referendum on the 20th of this very month, in only 4 days' time. And one of the basic questions in the draft to a new constitution is the question of the power resources. I'll come back to that. National resources policy, we have a recent draft. It will possibly be completed before the end of this year. National energy policy, similar. The master plan for energy options has been worked on now for almost 20 years. It has now been given to the Parliament for final discussion and to take it into the legislation. So many things are happening at the same time. This is the timeline for the various things. As I said, the Constitution is being reworked. law, of course, in different areas has been worked on now and then for decades. The resource policy has been taken up recently as a new tool in managing our resources effectively. Then the energy policy is started a bit sooner. Then the Energy Master Plan is here. And the Master Plan is a professional way of, hopefully, of weighing together the different aspects of every single energy project that is under preparation or may come under preparation in the future. Then we are looking at the environmental side of it, or the economical side, and so forth. From the perspective of sustainability, it's been a very, very thorough work. There are 80 national resources or power resources altogether in this plan, both geothermal and hydropower, and this has all been ranked according to certain criteria. And the idea is to establish then 3 sort of divisions. One is for utilization or for harnessing. A second is like a waiting group, not decided yet. The third one is for preservation. And so this is the hot issue in the Parliament today, these very days, how to take this into legislation, and if the politicians decide to follow the advices of the experts on this classification or not. Well, then the Republic's constitution in 2009, after the downfall of the banks, one of the decisions made was to revise or take a fresh look at the constitution of the Republic. And a constitutional assembly was selected. There was a debate then if this was the right legal way. Finally, a assembly was selected and given the mandate to draft a new constitution. The proposal for a new constitution has been delivered to the Parliament, and a national referendum, a guiding referendum, not a final word, will be held on the 20th of October. And the referendum is on 6 basic questions. Does the nation support these 6 basic points or not? And one of the most important points is this one. In the new constitution, do you want natural resources that are not privately owned to be declared national property? Yes or no? And the wording in the draft itself is, no one can acquire the natural resources or rights connected thereto as property or for permanent use, and they may not be sold or pledged. This is a basic thing about all natural resources that will come into the constitution if accepted, which I have no doubt it will be. Master plan, I've already discussed it, some 80 particular power projects. And this is then the simple path to go if a project is on a master plan. And if it is on a master plan and it says, yes, this is a good project for harnessing, it is accepted and approved, then we embark on this simple path. But the participation of the public has not ended, because where you see these pink squares, that is where the public can interfere in the process. Finally, a robust legal framework and civic participation practice is underway, very, very definitely. But will it be finalized in time? Or will it first be completed when the energy resources have been fully harnessed? We are running against time here. I don't think that what we are doing is a great guidance to the German people under these circumstances that prevail in Europe. Might possibly give some ideas or inspiration. I don't know, but I'm sure that if what we have been doing were sort of transformed to some of the developing nations that have abundance of natural resources and they don't know how to handle it, I think that could be a valuable example or route to follow. So, thank you.
Mr. Bjarnason, please stay with me for a minute. Thank you so much for this highly interesting scheme, especially the flow chart of the participation. I think we shall use this as the basis for the first workshop. I think this will help a lot. Now, honestly, one question I found out, you said there's a discussion and people should vote for whether these energy resources could be sold or not, and you say it will most probably not be that it could be sold to private companies, but can the state itself, like Iceland, sell it, for instance, to other countries in Europe? You showed the possible cables.
No, these power resources that are in public ownership today, either municipalities or the government, they cannot be sold to anyone ever. The next step might be, it has been worded, but no one has really taken it seriously though still, those energy resources that are in private possession, these should be nationalized or confiscated. That has not been discussed, but the idea has come up. And we say simply that no single person should have the rights to own natural resources and use them for their own sort of privilege. That's a basic and very serious question, but we have not come that far.
Thank you so much. We're way in the schedule, but maybe there's one or the other question to Mr. Bjarnason, because there was a totally different presentation compared to the ones we saw yesterday. So maybe there's one or two questions about geothermal, maybe.
I have a question about existing projects in Iceland. If you look at a project like Karanjuka, if you see it, you ask yourself, how much does Iceland own and how much does an international company like Alcoa own? And is that in conflict with the constitution which you are just giving yourself?
It's a very simple answer. Okay. I was the head of the negotiating team for the Alcoa contract. Alcoa does not own anything except the power contract. But the project, the Karanjuka project, is entirely owned by the state and will be.
One more question over there?
Yes, and you say no natural resources can be owned by external or by single person owners, but can they be leased for 200, 300, 400 years?
They can be leased, yes. And this part of the debate now is for how long. There was a proposal of 30 years, which the power industry said is far too short. No one will invest in a power project if it has to be returned after 30 years. A more common approach would be 60 years. That's in line with what is done in Norway. 60 years plus a further extension if the holder of that license has operated it in a proper and prudent way.
Maybe one last question, otherwise we will have enough time during the breaks and after the workshops. Okay, thank you so much for your presentation.
Thank you.
Thank you.